Okay, so I'm going to teach you how to memorize trigonometric equations, the differentiation of trigonometric equations, the differentiation and integration of trig equations, right? So there's a little table I've drawn, but it's a song, right? Once again, welcome to the Grantson Academy. My name is Bright Kwamina Grantson, and I'll be your teacher in this tutorial, right? So we know the basic trigonometric identities or functions, right? So if you are given a function of y, right, what will be the dy dx of these functions, right? So let me extend this table. So if I have sine, I'll get what? Cos, right? So there's the song. Trigonometric differentiation, sine, cos, cos, negative sine, tan, s, sec square x. I'm taking it again. It's from the song Everybody Blow Your Trumpet. In Ghana, we have a praise and worship song we sing at church. Everybody blow your trumpet. Pa na 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 na. Pa da 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 da. So that's the replace lyrics, right? So trigonometric differentiation, sine, cos, cos, negative sine, tan is sec square x. So repeat after me. Trigonometric differentiation, right? So trigonometric differentiation, sine, cos, cos, negative sine, right? That's the lyrics. Tan is sec square x, where x is the angle. Okay, so that's for the trigonometric equations. So trigonometric differentiation, sine, cos, cos, negative sine, tan is sec square x. Now, ironically, or in a nice way, the same song can work for integration, because when I integrate these values, let me copy this table. When I copy this table and paste it here, right, and I change this one, instead of the differential, I integrate. I'm integrating these functions, right? So if you integrate cos, you get sine. If you integrate sine, you get negative. This negative moves to the other direction, right? And if you integrate sec square, you are getting tan. So you get the idea. So it's like killing two birds with one stone. The same song can help you in differentiation, and it will also help you in integration, right? So this is just one part of it. Now the second one, the next one is much more crazier. So let me copy these ones. The second part of the song, right, or the second song is this. Dsec, sec, tan, dcosec, negative, cosec, cot, dcot, cosec, cot, dcot, negative, cosec, cosec equal to negative cosec square x, the negative. Over here, we are stressing much more on the negative. Okay, so this sec means the differential of sec is sectan. The differential of cosec is negative cosec cot, and the differential of cot is negative cosec square. And the square is just like saying negative cosec times cosec. So I'm going to take it again. Dsec, sectan, d cosec, negative. Cosec, cot, d cot, negative. Cosec, cosec equal to negative. Cosec square x, negative. There's a song in Ghana that we use for praise and worship. Abodinina yiwayo erade menso meyiwa yedenina. Abodinina yiwayo erade menso meyiwa yedenina. So like and subscribe, okay? Like and subscribe. Alright. So let me give you the lyrics of the second one. It says what? This sectan d cosec negative cosec cot d cot negative cosec equal to negative cosec square x and the negative, right? So once again, this becomes a differentiation. If you have a y function of this, if you differentiate, you are going to get what? dy dx, right? dy dx is this, right? Now, in the same vein, right? If we integrate, right? If we integrate these functions, we are going to get this one. The integral of what? Sec tan will give you sec. The integral of cosec cot, in this case, there's an angle here. The integral of cosec cot gives you cosec. And the integral of what? Cosec square equals negative cot, right? So learn and memorize these songs, and it will help you in your calculus lessons, especially when you come to the trigonometric substitutions. And okay, let me teach you that one too. So if you have root of a square minus x squared, right? This negative is bad. A sign in Ghana, when we say sign, it means go back, right? If you are coming and you are walking to this direction, they say sign. Sign means go back, right? So it's a negative direction. So whenever we see this one, we have to replace it with what? X equals a sine theta, right? Whenever you are solving a trigonometric radical, for example, something like the integral of 9, the root of 9 minus x squared over x squared, and there's a radicand of a perfect square or difference of two squares, you can use this mnemonics. Another one too is the root of a square plus x square. Now, immediately you see plus, how do you write t? The plus represents the t. The plus represents the what? T. So that gives you tan x equals a tan theta, right? X equals a tan theta. Then use it for your what? Trigonometric or integral of what? Something like this. But this one I want to use sine, right? Because it looks like sine. And another one is the third one. When you have the opposite of this, that is x squared minus a squared, right? This one gives you sec, right? So x equals a sec theta. So by all means, you can get this one, you can get this one. You have to have in mind that there are 3 substitutions. So this and this, and the final one will be what? Sec. Are you okay? So this will be a few. There are more identities there. Okay, if I can compile it into one video, it would be nice. Now let's look at the compound angles. Now, if I have sine A plus B, right, and I want to expand this with a mnemonic, I formed a mnemonic called sac B, cast B, right? Sac B, cast B. Now, with the sac B, cast B, these ones are silent, right? T and K are silent. So in a way, this mnemonic SAC B CAS B will form what we have, what sine A, and this gives you cos B, right? With the sign, if here is plus, here also be plus. So plus, this is C. So that gives you what cos. This gives you A. This gives you sine. This gives you what B, right? So whenever you have a compound angle, sine A plus B is the same as SAC B CAS B. Eh? In Ghana, when we are speaking tree or when I say sack, when they sack you, you go back. When they sack you, right? When they are sack you, it's like you've been cast away. You assign or you punish, you sack you, right? So sack B, cast B. For example, B has done something bad. Hey, sack B, cast B, sack B, cast B, sack B, cast B, right? So the K and the T are silent. So sine A cos B cos A sine B. Now, the same idea works with the negative. So sine A minus B equals the same SAC B cos B. So sine A cos B minus cos A sine B. Right? Now, let's come to the cos. If I have a compound angle of cos A plus B, right? How do I expand this one? So, for example, if you are going to knock on somebody's door, right? This is somebody's door. And you are knocking. Bang, 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 bang. If the person does not want to accept you, or you are not welcome, they'll tell you to go back. In Ghana, when they say go back, it means sign, right? So I'm knocking on the door. Koko, sign, sign, right? Koko, sign, sign. I'm knocking on the door. I'm knocking. Hey, you are not welcome. So in Ghana, when they say sign, it means go back. Sign means back or negative. Alright. So Koko sign sign. So Koko sign sign means that this one will mean cos A cos B. And sign, because sign means go back, it will become what? Minus sine A sine B. Get it? The co means cos. Right? Koko sign sign. We are working with A and B. So Koko sign sign. When I say Koko, you respond sign sign. Koko, Koko, nice one. So similarly, if it is cos A minus B, right, it's going to be the same Koko sign sign. So cos A cos B. But the sign, if here is plus, here will be minus. So if here is minus, here will be plus. Sine A sine B. Right. Then the last one is the tan. If you have tan A plus B, it's going to be what? Tan A plus tan B over 1 minus tan A tan B. Right? So the tan there, they are coming together, right? But it will change, the sign will change at the latter part, at the denominator. So tan A minus B is going to give you tan A minus tan B all over 1 plus tan A tan B. So let's have a review of what we've done so far. It's a 15 minutes class or something. We start with the trigonometric differentiation. So trigonometric differentiation, sine, cos negative, sine, tan a sec square x. Repeat. Trigonometric differentiation, sine, cos negative, sine, tan a sec square x. Then the other ones. Dissec, sectant, d, cosec, negative. Cosec, cot, d, cot, negative. Cosec equal to negative. Cosec square x negative. We are stressing on the negative. That you shouldn't forget the negative. Again, dissec, sectant, d, cosec, negative. Cosec, cot, d, cot, negative. Cosec equal to negative. Cosec square x negative. Trigonometric differentiation, sine, cos, negative, sine. Tan yes x square x. Sine, cos, negative, sine. Tan is x square x. Dissec, sectant, d, cosec, negative. Cot, d, cot, d, cot, d, cot. What is it? Dissec, sectant, d, cosec, negative. Cosec, cot, d, cot, negative. Cosec equal to negative. Cosec square x negative. So that's it. So the the same thing will work for integration, right? When you are going to use integration, when you integrate this, when you integrate cos, you get sine. When you integrate sine, you are getting the negative here to this part. When you integrate sec square, you are getting tan. The same thing when you integrate sec tan, you are getting sec. When you integrate cosec cot, you are getting cosec. When you integrate cosec square x, you are getting negative cot. When you integrate cosec cot, you are getting negative cosec. The negatives will go. So, like and subscribe to my channel. I'll be uploading more content. My name is Bright Kwamina Grantson, and this has been the Grantson Academy, the Grantson Maths Academy.